Happy Halloween, guys. Trick or treat. Oh, you want a treat? Well, here, let me show you how to find the Ka of an acid from a titration curve when you start with acid and you add base to the equivalence point. Now, the first thing is, if you're trying to find the Ka with a titration, you don't need to go any farther than the equivalence point. But maybe you did. I don't care. So, here we go. At the equivalence point, we have added just as much base as we have of acid. That's the definition for equivalence point. What you'll notice about the titration curve is that there's a buffer region here. The buffer region is the region where you've added just enough base that you have some conjugate base in solution, but you also have some acid in solution. So as you keep adding base, rather than creating more OHs or consuming more H pluses, you're actually just converting conjugate acid into conjugate base. So the pH doesn't change very much because the H plus concentration isn't being affected by you adding base. Here's the point though. The best place for the buffer region, or where the buffer is flattest, or the middle of the buffer region, is the point at which you've added half as much base as you have half as much base as you started with of acid. Which means that in your solution, your concentration of base is equal to the concentration of your acid. You started with a full amount of acid, and you've titrated half of it away. So let's say it started at 20. You started at 20, half of that's gone, and you had added 10 of these. See how halfway gets you so that the base equals the acid, especially since you started with 0 base? Anyways, that's how it goes. Now, the greatest part about the buffer region is we have a special equation called the Henderson-Hasselbalch Equation, or Henderson-Hasselbalch, I don't know. pH equals pKa plus log concentration of base over acid. And the greatest part about this point in the buffer region, exactly halfway to equivalence point, in this case half of 16.82 is 8.31 milliliters. The pH at that point has the concentration of base and concentration of acid equal, which means base divided by acid is 1, and the log of 1 is 0. So at this point, exactly halfway to equivalence, whatever your pH was there, I don't know, 3.62, that is the pKa for the acid that you're using. And lucky for you, there's a nice easy way to figure out the Ka from the pKa. If the pKa is 3.62, the Ka is 10 to the negative 3.62. On your calculator, I type 3.62 negative, and then I use the 10 to the power of button, and I get 2.4 times 10 to the minus 4. And that's how you find the Ka of an acid from the titration curve. The pKa of the acid is the same as the pH, halfway to equivalence. Happy Halloween. Best of luck.